Okay, next we're looking at this famous ladder problem here. I know this is a business calc, but we have had, some uh, other problems that just kind of bring in what we are doing. So this problem is shows up in every calc class when you're doing related rates and first learning implicit differentiation. So let's take a look here. So we have this ladder. I know my art, it's horrible. Maybe I should have did some red in here just to show this is a brick building. There, now it's so much better. Okay, so we have this ladder. It tells us that it's 10 feet, and so probably should include units. 10 feet. It's not 100 feet or some crane or whatever, but it would apply the same way. And it's up against this wall, and what's happening is it's being pulled this way, right? And the rate that it's being pulled is 3 feet per second. This problem was nice. If you opened up your text in 3.3, you would see that it gave you these hints below. dx dt is 3. Again, they gave that to you, but that's what this is right here. The change of x, it's pulling along the ground, right, with respect to time. So the change of x with respect to time, dx dt. Okay, and then they tell us when x is 8, so we know that that is 8. We don't know the height y necessarily. Not yet, but that's the problem. Okay. So to begin, right, implicit differentiation, I need an equation. There's nothing here. Well, good old right triangle, right, and Pythagorean theorem. Haven't seen that in a while in this course, I think. So we have a squared plus b squared equals c squared, right? A squared plus b squared equals c squared, where c is the hypotenuse, which is the 10, and the a and the b are the legs. It doesn't matter which order. X squared plus y squared. Now, that's our equation we need to start with. Remember, don't start plugging in variables. Do derivative. Okay, derivative with respect to time. I'm going to cheat and just go over the whole thing. Okay, derivative with respect to time. So, derivative of x squared, 2x. But variables don't match, dx dt. Y squared is 2y, variables don't match, dy dt. Derivative of 100, still 0. Doesn't matter if it's 10 squared or not. You don't bring down the 2 and say 2 times 10, right? It's constant. Derivative of any constant, 0. Now let's look at what was given. We know x is 8, right? I could plug that 8 in there. We know dx dt. We know that this was 3. I don't know this, and I don't technically know y yet. It's saying what is dy dt, so this, for sure we don't know, right? The y, though, we can go back to this Pythag that we had done and get y. Okay, I wanted to do the derivative first because if you find y immediately, like you have constants and it's misleading. Like, what do I do next? I don't know. So let's write this again. X squared plus y squared equals 100, and x was 8, right? So when x is 8, I know y then will be, let's see, that's 64, so y squared equals 100 minus 64 is 36, so y has to be 6. I don't need the negative, right? I can't have a negative height on this building, so y is positive 6. Now I have everything because I could plug in that y. And again, I don't know dy dt. That's the problem. We have this 2 out front. We have this 2 out front. And a simple equation to solve. 2 times 8 times 3 is 48. Plus 12 dy dt. Solve for dy dt. I can kind of see it's negative 4, but let's go ahead and do it. 12 dy dt equals negative 48. dy dt equals negative 4. Now this is a word problem, so what does that mean, right? The rate that this ladder is sliding down the wall is -4. So the rate the ladder slides down the wall is 4, let's see what units we're in, feet per second. See, I don't say it slides down a negative, right? The negative is telling me it's sliding down. It's not, right? I don't pull this ladder that way and then it goes up. The ladder's gonna head down. So that's it. Now this happens, under the circumstances. So under those given conditions. Because when the foot of the ladder was 6 feet away, it could change things. So when it is 8 feet from the wall and all that other stuff's happening, that's when it is dropping 4 feet per second.